Welcome to another video on the igetChem channel where we help you learn chemistry the easy way by showing you how to solve problems. Today's video is on the pH calculation of a weak base solution. So let's take a look at the problem and we will get right to the answer. The Ka of a certain monoprotic acid HX is 3.87 times 10 to the minus 6. Part A, calculate the Kb of its conjugate base, X minus. And Part B, calculate the pH of a 0.0475 molar solution of NaX. So first of all, the problem tells you that there is this weak acid HX, which has a Ka value equals to 3.87 times 10 to the minus 6. So just to remind everyone, if you have a acid, when it is dissolved in H2O, it will donate a proton to the water molecules, making them H3O plus, and itself becoming X minus. So in this case, what is the acid on the left side of the equation, or what is acting as the acid, is HX. And then on the right side of the equation, the conjugate base of HX is X minus. So the Ka value is the equilibrium expression for that particular reaction. So you're given Ka, but you want to use that to calculate Kb of the conjugate base, which in this case, as we have said, is this X minus. So let's look at the reaction in which X minus is acting as a base. So let me just write that down. So we want to calculate Kb. So let's figure out what X minus does in water. So as a base, X minus will abstract a proton from water molecules, turning them into OH minus and itself becoming HX. So you see in this reaction, on the left side, X minus is acting as a base, and on the right side, it is producing is conjugate acid, which is HX. So we generally say that HX and X minus is a conjugate acid-base pair because they are related to each other via an acid-base reaction. So in this case, what we really want to do is to calculate the value for Hb given the value for Kb given the value for Ka of its conjugate acid. And we all know that the relationship between Ka of the acid and Kb of its conjugate base is that Kw is equal to Ka of the acid multiplied by its Kb value of the conjugate base. So in this case, we know the Ka value for Hx, and we want to use that to calculate the Kb value of the conjugate base, which is X minus. And of course, the value for Kw, which is the autoionization constant of water, is 10 to the minus 14. So all we would need to do is to calculate Kb is to just take 10 to the minus 14 and divide that by the Ka value for Hx. And from that, we will get 2.58 times 10 to the minus 9. So that's the answer, 2.58 times 10 to the minus 9. So that's for part A. And now for part B, what we want to do is to use the Kb value to calculate the pH value of a solution containing a certain concentration of this base X minus. So it tells you in the problem that you have an NaX solution that is 0.0475 molar. So we know that most sodium salts are soluble, so we are going to assume that when NaX dissolves in water,